Will open source or closed source AI skills win the humanoid robot race? Today on AI News, we're taking a closer look at the top 9 humanoid robots to run on OpenMind's framework to determine which has the most value. Starting with number 9, Ubtex Walker Tiancong. This robot packs 550 tera operations per second of computing power, as well as a hot swappable battery for 3 hours of uninterrupted operation, and it stands at 172 centimeters tall, featuring 42 degrees of freedom. And in terms of its artificial intelligence, it supports integration with large-scale voice models for natural language processing and interaction with humans, as well as comprehensive environmental perception, which is supported by its onboard stereo vision 3D cameras and 6-axis force torque sensors, as well as advanced face detection and lip reading. And when it comes to this robot's dexterity, it handles a single payload of 3 kilograms with sub-millimeter positioning accuracy. Next, there's number 8 from Magic Lab. This is MagicBot Z1, and this is a slightly smaller full-size humanoid robot standing at 140 centimeters tall and weighing 40 kilograms, featuring up to 50 degrees of freedom. And in terms of its onboard hardware, it features 3D LiDAR, as well as depth vision and dual fisheye cameras, as well as a battery capacity of 10,000 milliamp hours to power the robot's max knee torque of 130 newton meters. And in terms of its walking speed, it can achieve up to 2.5 meters per second with support for over-the-air upgrades powered by its 8-core high-performance CPU. But Fourier is posing some stiff competition with number 7, its GR3 humanoid robot. This is another full-size humanoid robot standing significantly taller at 165 centimeters and weighing 71 kilograms. And in terms of its onboard hardware, it features RGB and structured light camera modules, as well as a 4-microphone array with sound source localization and 31 distributed pressure sensors for tactile feedback in its hands. And it features up to 55 degrees of freedom with a single arm load capacity of 3 kilograms and a battery run time of about 3 hours on average with hot swappable batteries for continuous use. But something else that stands out about this robot is its exterior automotive grade upholstery, which is able to eliminate pinch points to make the robot safer and more approachable with human interaction in home settings as well as in the office. Next is number 6, the Dobot Atom Max, which features 41 degrees of freedom and 6 degree of freedom hands. And in terms of its onboard hardware, it features 60 frames per second vision system, Intel RealSense D455 depth sensors, as well as an onboard 1500 tera operations per second AI module for real-time edge computing. And with sub-millimeter precision and 360-degree environmental awareness, the Dobot Max is ready to handle real-world tasks using its onboard 16GB graphics card. And something notable about this robot's battery is that it's not only hot swappable, but also it features 15,000 amp hours of power, which in theory should allow this robot to run for well over 3 hours, although its runtime hasn't been specified. But how does it compare to number 5, which is Ubtex Walker S2? This is also a full-size humanoid robot, but it stands at 176 centimeters and weighs 70 kilograms with 52 degrees of freedom throughout its body and 2 meters per second walking gait. And when it comes to this robot's dexterous hands, it packs 11 degrees of freedom in each hand, as well as 6 tactile sensors, which help the robot to grasp up to 7.5 kilograms per hand with a singular finger grasp power of 1 kilogram. And it supports LLM voice interaction and features a 4-inch circular facial display, as well as a 4-microphone array with 2 speakers. And the Walker S2 is already working in the real world utilizing its BrainNet 2.0 plus co-agents, building a dual-loop AI system to carry out real-world long-horizon tasks. Next we have number 4, Limex's Ali Humanoid. This is a 165 centimeter tall humanoid weighing 55 kilograms with 31 degrees of freedom throughout its body, and it features a modular design with a 6-axis IMU, plus a head-mounted depth camera, chest-mounted depth camera, as well as support for a modular SDK. And this robot is already carrying out dexterous tasks in the real world using its 9500 milliamp hour battery, which lasts between 1.5 to 2 hours. But tell us in the comments whether or not you think this robot should feature a hot swappable battery as well. Next, we have number 3, P&D's Atom Robot, which stands 167 centimeters tall and weighs 60 kilograms, and packs 340 newton meters of joint peak torque with up to 43 degrees of freedom throughout its body. But what really stands out about P&D Botics Atom is that it features fully modular robotics hardware, meaning that its quasi-drive PSA series actuators integrate the motor, P&D network controller, and gearbox, which provides a wide range of reduction ratio parameters for selection. Next, number 2 is AGI Bots X2. This is a miniature robot that stands at just 131 centimeters tall and weighs 39 kilograms. With up to 25 degrees of freedom or 30 degrees of freedom with the X2 Ultra. And in terms of this robot's battery, it packs 500 watt-hours of power to operate the robot for about 2 hours continuously, while the charge time takes about 1.5 hours, but it does feature direct charging as well as swappable batteries, and an optional auto-charging dock for the X2 Ultra. And as for this robot's hardware, it features a microphone array, dual RGB cameras, full-range 3D LiDAR, as well as an RGB depth camera, plus swappable end effectors, meaning that you can use the Omni Picker or its 10 degree of freedom Omni Hand for dexterous tasks. Plus, this robot is extremely agile, being able to complete flips and spins on its own, as well as balance on bicycles. And finally, number 1 is Booster's K1 robot. This robot is priced on the website at $5,999, and it features 22 degrees of freedom, all packed into a 95 centimeter tall package weighing just 19.5 kilograms. And it features a surprisingly powerful 200 tera operations per second of onboard computing power with a circular 6 mic array and speaker setup. Plus, the robot features a surprisingly powerful max peak torque of 60 newton meters, and this is thanks to its 5,000 milliamp hour battery, which powers the robot for just under an hour and a half, achieving a walking speed of just under a half a meter per second. And as a bonus, here is a completely open source DIY humanoid robot project which the creators are calling Robo Party, and it was founded about a year ago. But this allows anyone to 3D print the parts for their own humanoid robot and assemble it, as well as control its onboard artificial intelligence. But tell me in the comments down below whether or not you would build something like this from scratch, or if you'd rather buy it pre-built. Anyways, like and subscribe, and check out this video here for more in the latest in AI news.